The performance expectation K-PS2-1 or Kindergarten Physical Science 2-1, there are a few things that we want to explore. First, we want to explore the actual statement, plan and conduct an investigation to compare the effects of different strengths or different directions of pushes and pulls on the motion of an object, along with its clarification statement and its assessment boundary. From there, we would take a look at the three dimensions of this performance expectation, the science and engineering practice, the disciplinary core ideas, as well as the cross-cutting concepts. And then we want to take a look at the connection boxes below. So let's take a look. When we look at the kindergarten or any of the K2 standards, we really want to emphasize foundational learning and also, probably more importantly, opening up their natural curiosity and having them make a connection between what they already know and new learning. In the case of K-PS2-1, we are talking about forces. In this entire universe, forces only come in two flavors, push and pull. Initially, we'd want students to recognize each of these forces. From there, we want students to be able to verbalize their understanding of these forces, draw models of these forces. What a great way to get out the easels and tempera watercolor paints. And also to verbalize their predictions of pushes and pulls on an object. A good place to start is by looking at the clarification statement for this PE. The clarification statement will give you ideas of how students can achieve this standard. I mention this because please remember, in order to achieve this standard or any other NGSS standard, students must demonstrate their understanding of the standard. The clarification statement reads as follows. Examples of pushes or pulls could include a string attached to an object being pulled, a person pushing an object, a person stopping or rolling a ball, and two objects colliding and pushing on each other. For example, teachers could start by asking students what they think the word force means. Facilitated questioning could then get to the idea that a force is a push or a pull. Teachers could then use a video, story, and/or a playground walk to provide students with not only the idea of pushes and pulls, but also to have the student point out pushes and pulls. Students should also be given the opportunity for scaffolded play to discover and make connections about pushes and pulls. An example of this would be setting up centers with different things that students could push and pull. For example, pushing or pulling a ball to see how far it would roll, rolling two of the same size balls towards each other and predicting the outcome. Use your imagination and allow the students to use their imaginations as well. Finally, we want to provide the students with an opportunity to read, write, listen, and/or speak about what they know about pushes and pulls. Again, use your imagination and think about what would be a fun way to learn this concept. Much of this is shown in the disciplinary core ideas box, always shown in orange, where the nuts and bolts of the science for this PE is described. Another useful tool is the assessment boundary. The assessment boundary provides the minimum level of understanding that the students must demonstrate. The assessment boundary reads, assessment is limited to different relative strengths or different directions, but not both at the same time. Assessment does not include non-contact pushes or pulls, such as those produced by magnets. In this case, we won't need magnets. We can save that for the third grade, the next time students will see this standard. We also don't want to confuse students by having them think about not only the strength of a force, push or pull, and the direction of the force at the same time. Again, we let them experience the idea of force and connect those ideas to what they already know. Then, when they matriculate to third grade, we get back into the idea of force and kick it up a notch or two in order to establish the understanding at the higher grade level. This is shown in the connection boxes under Articulation of Disciplinary Core Ideas, or DCIs. Let's look now at the description of what we call the three dimensions of an NGSS performance expectation, or PE, namely the science and engineering practices, or SEPs, always in blue, the disciplinary core ideas, or DCIs, always in orange, and the cross-cutting concepts, always in green. We will start with the DCIs, again always in orange. They describe the nuts and bolts science of the PE and describe the understanding of the science students should be able to demonstrate by the end of their third grade level. In this case, the DCIs are describing what students should understand about forces. We talk about the DCIs when we talked about the assessment boundaries. There are 8 science and engineering practices as shown on the screen. They are always in blue. Please remember, although the DCIs change in both ideas and complexity as students matriculate from kindergarten through 12th grades, The SEPs are the same 8 practices that students will see from the beginning to the end of their education. The SEPs describe how students should do science on their way towards understanding. This specific performance expectation focuses on planning and carrying out investigations. Ideally, kinder teachers would provide the opportunity for a class project in which students would collectively plan and carry out an investigation of pushes and pulls to satisfy the DCIs. This investigation does not have to be complex, especially if this is the first time you're trying it. Like all great teaching, keep it simple to start and add to it as your skill and understanding increases. Like the SEPs, the 7 cross-cutting concepts are the same 7 concepts that students will see from kindergarten through 12th grade. They are always in green. The concepts are a way for students to think about science, a lens and perspective, if you will. In this case, the concepts focus on cause and effect. In other words, if I do this, then this will happen. Students should think about the idea of cause and effect as they explore and otherwise play with forces as they continue on their path towards understanding this phenomenon. With regards to this or any PE, a specific SEP and cross-cutting concept are emphasized, but please realize that all 8 science and engineering practices and 7 cross-cutting concepts are in play and can be utilized to help students with their understanding of the phenomena at hand. Lastly, let's take a look at the connection boxes of this PE. The first line describes connections of this concept to other DCIs in kindergarten. In this case, there are no other concepts. Next, as mentioned earlier, students will see more about push and pull in 3rd grade. Finally, we see that this performance expectation connects to both literacy and mathematics state standards, and the respective standards are listed and linked in the document. I hope this video helps you to better understand this NGSS performance expectation. As always, if you have any questions about this video or other science-related items, please contact one of our science team members for help. Also, please consider subscribing to our YouTube channel in order to better access this and other science education videos. Thank you.